Hello there and welcome back to the Sleepy Cosmos channel. Tonight we are going somewhere that has no postcard, no photograph that does it justice, no landmark that announces your arrival. Tonight we are going to the void, not the darkness of deep space between stars, which already feels enormously empty to most imaginations. Not the cold dark between galaxies in a cluster, which is empty enough to make your sense of scale quietly collapse. We are going further than that. We are going to the places between the great structures of the universe itself, to the enormous, ancient, almost incomprehensible regions of space where even galaxies are rare, where even the tenuous threads of matter that weave through most of the cosmos grow thin and disappear. We are going to the cosmic voids, and we are going there not to feel lost, but to feel something far more useful to a tired mind. We are going there to feel small in the most restful way possible, small and quiet, and briefly unburdened from everything that fills a day with weight. The void is enormous, an enormous emptiness entered slowly and gently, in the dark, lying still, is one of the most restful things there is. If you enjoy these slow journeys through the cosmos, I want to invite you to like this video and subscribe to the channel, or leave a thought in the comments below. It helps other tired people find their way here. But for now, simply settle in. Let your shoulders drop just a little. Let your breathing slow to its own natural rhythm, and allow your mind to wander outward. Past the clouds and the satellites and the moon and the planets. Past the nearest stars and the spiral arms of our own galaxy. Past the local group of galaxies and the larger clusters beyond. Out to where the universe's architecture becomes visible at the largest scales, and the emptiness between that architecture becomes something you can almost feel pressing gently against you from all directions. We are almost there. Let's begin. The universe, viewed from far enough away, does not look like a uniform sea of stars and galaxies distributed evenly in all directions. It looks like a web. A vast three-dimensional web of extraordinary delicacy and extraordinary scale. Astronomers call it the cosmic web, and it is one of the most beautiful and unexpected structures in all of nature. The cosmic web has three kinds of components. There are the nodes, dense clusters of hundreds or thousands of galaxies packed together by gravity into some of the most crowded environments in the universe. There are the filaments, long thread-like structures that connect the clusters, rivers of matter stretching across hundreds of millions of light years, carrying galaxies along their lengths like beads on a thread. And then there are the walls, broad flat sheets of galaxies that form the surfaces of enormous three-dimensional bubbles, and the bubbles themselves are what we are here to visit. The interiors of those bubbles, the spaces enclosed by the walls and filaments, are the cosmic voids, the great emptiness between the great structures. The spaces that make up most of the volume of the observable universe. Most of the observable universe, by volume, is void. Not filament, not cluster, not wall. Empty, or nearly empty. The universe is far more nothing than it is something. And tonight, for a few quiet hours, we are going to drift in that nothing and find out what it has to offer. The cosmic web was not always here. In the earliest moments of the universe, matter was distributed almost uniformly in all directions. Almost, not perfectly. There were tiny fluctuations in density. Some regions were ever so slightly denser than the average, some were ever so slightly less dense. These differences were incredibly small. If you measured the temperature of the early universe in different directions, the variations were about 1 part in 100,000, barely a whisper of difference. And yet, those whispers were enough. Gravity is patient and gravity is sensitive. Over millions of years, and then hundreds of millions of years, the slightly denser regions pulled more matter toward them. The slightly less dense regions lost matter to their denser neighbors. The small fluctuations grew. Denser regions became denser. Less dense regions became emptier. What started as a nearly uniform fog slowly differentiated into a web. The filaments and walls and clusters grew from the dense regions. The voids grew from the less dense ones. This process, which astronomers call gravitational collapse and structure formation, has been running continuously for 13.8 billion years. The cosmic web we see today is the result of that long and patient differentiation. It is the universe having slowly sorted itself out over cosmic time, and the voids are the residue of the places that were slightly emptier to begin with. The regions that lost the argument with gravity and contributed their matter to the surrounding structure, leaving behind a volume of space more empty than almost anywhere else. To understand the scale of a cosmic void, it helps to first understand the distances we are dealing with. The nearest star to our Sun is about 4 light years away. The Milky Way galaxy is about 100,000 light years across. The distance to the Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light years. The nearest large cluster of galaxies, the Virgo cluster, is about 50 million light years away. These numbers are large enough to dissolve the ordinary sense of distance. But a typical cosmic void is between 100 and 300 million light years across. The largest known voids are considerably larger than that. If you placed our entire local group of galaxies, the Milky Way and Andromeda and all their satellite galaxies and all the smaller members, at the center of a large cosmic void, the nearest wall of that void would be further away than the Virgo cluster is from us right now. The void would be so large that it would contain our entire observable local universe with enormous room to spare. And inside that void, you might be able to travel for tens of millions of light years in any direction without encountering a galaxy. You would be in the truest, most complete emptiness that the universe currently offers, and it would be, in its way, extraordinarily peaceful. The largest void we currently know of has a name that suggests its enormous scale. The Boats Void, named after the constellation in whose direction it lies as seen from Earth, is approximately 330 million light years across. It was discovered in 1981 by Robert Kirshner and his colleagues while they were surveying the distribution of galaxies in that part of the sky. They expected to find galaxies distributed more or less uniformly throughout the survey volume. Instead, they found almost nothing, a vast region of space containing very few galaxies. At first there was uncertainty. Perhaps the observations were incomplete, perhaps some instrumental effect was creating the appearance of emptiness, but further surveys confirmed it. The Boats Void was real, a roughly spherical region of space more than 300 million light years across containing, by the standards of the surrounding universe, almost nothing. When astronomers tried to count the galaxies inside it, they found about 60, in a region that, based on the average density of the universe, should have contained something like 2,000. It is one of the most empty places we have found, and it has been setting there in the direction of the constellation Boats, largely undisturbed for billions of years, just quietly being empty.
Doing what voids do, which is, mostly, to continue being empty, and to grow. Because the universe is expanding, and as it expands, voids expand with it.
Voids grow over cosmic time. As the surrounding filaments and walls drain more matter into the clusters at their nodes, the voids become slightly more empty, and the expansion of the universe causes them to become physically larger even as they drain. In the very far future, if the expansion of the universe continues to accelerate as it currently appears to, the voids will eventually expand fast enough to overcome the gravitational binding of even clusters of galaxies. The clusters will be torn apart, the filaments will dissolve, the walls will thin to nothing, and the universe will become mostly void, with isolated galaxies or even isolated stars drifting in a sea of expanding emptiness too vast for light from one island to reach another in any reasonable time. This is sometimes called the Big Rip scenario, or the heat death scenario, depending on exactly how the acceleration proceeds. But these are futures so remote that they make the 5 billion year future of our Sun feel like tomorrow morning. For now, the voids are large but bounded. The cosmic web still holds its shape, the filaments still connect the clusters, and the voids are still accessible, in imagination at least, to anyone who is willing to drift outward past the last galaxy and into the clean cold, dark expanses beyond. Now before we go further, I want to pause for a moment and notice where you are right now. You are lying still or sitting quietly somewhere warm. Your body is in contact with a surface that is supporting it entirely. You do not need to hold yourself up. The surface is doing that work for you. Your breathing has probably slowed a little since we began. Your thoughts have probably become quieter. If you have found your way here for the first time tonight, I want you to know that there are many more journeys like this one on this channel. More slow travels through space and history and the natural world's quieter corners, each one made for evenings like this one, if you would like to find them. You can subscribe to the channel and they will be there whenever you need a place to rest your mind. Now back to the void, which is waiting patiently, as it always has. The void is very good at waiting. When astronomers say that cosmic voids are empty, they mean empty by cosmic standards, which is not the same as absolutely empty. A cubic meter of space inside a cosmic void contains, on average, far less matter than a cubic meter of space anywhere else in the observable universe. But it is not a perfect vacuum. There are atoms in the void, hydrogen mostly, the most common element in the universe. These atoms are spread so thinly that the density is almost incomprehensible by everyday standards. In the densest parts of the interstellar medium inside our own galaxy, there might be 1 million atoms per cubic centimeter. In the intergalactic medium within a galaxy cluster, there might be 1 atom per cubic centimeter. In the void, the density might be 1/1,000,000th of that, 1 atom per million cubic centimeters. To find 1 atom in the void, you might need to search a volume of space roughly the size of a large room. That is a density so low that the word thin barely begins to apply. And yet, it is not zero. There is matter there. Very little of it. Very lonely, very cold, very spread out. But present. The void is not truly empty. Nothing in the universe is truly empty, except perhaps in a quantum mechanical sense that is complicated enough to set aside for tonight. The void is instead very nearly empty, and very nearly empty at cosmic scales is close enough to empty that the distinction barely matters. You are in a place where the nearest atom might be several meters away in every direction, where the nearest star might be tens of millions of light years away, where the nearest galaxy might take light as long to reach as the current age of the universe has lasted. That is what the void offers. That and something else we have not discussed yet, because the void is not only made of the matter we can see and measure, it is also made of something we cannot see at all. Dark matter fills the universe. It does not emit light, it does not reflect light, it does not absorb light. It interacts with ordinary matter only through gravity, and because of that, it is extraordinarily difficult to detect directly. We know it is there because of its gravitational effects. The stars at the edges of galaxies orbit faster than they should, given the amount of visible matter in the galaxy. Something is providing extra gravity, something invisible and massive. Galaxy clusters bend light from background galaxies more than the visible matter alone could account for. Something is providing extra gravitational lensing. The large-scale structure of the universe, the cosmic web itself, formed in ways that match computer simulations only when dark matter is included in those simulations. Without dark matter, the simulations produce a universe that looks nothing like the one we observe. With dark matter, they produce something that looks remarkably like it. Dark matter is therefore one of the most well-established components of the universe. Even though we have never detected a single dark matter particle in any laboratory on Earth, we know it exists because we can see its shadow, because we can measure the shape of the space it bends, because without it, the universe would not be the universe. And dark matter is in the voids, not in the dense filaments and clusters where ordinary matter has collected, but present throughout the void in a thin and ghostly halo. The void is not only made of thin hydrogen gas, it is also permeated by an even thinner fog of dark matter, slowly responding to gravity, slowly flowing toward the walls and filaments under the influence of the same large-scale gravitational potential that shapes the cosmic web. The void is almost empty of ordinary matter. It is even more empty of dark matter, but it is not empty of dark matter entirely. Even here, in the most tenuous regions of the universe, the dark matter makes its quiet presence felt, not loudly, not in any way you could see or touch or measure without extraordinary instruments, but it is there. It is always there, everywhere in the universe, invisible and patient and inexorable and present. Some galaxies live in voids, not many. By the standards of the surrounding universe, the void is sparsely populated indeed, but a void 300 million light-years across is large enough that it contains some matter, and some of that matter has coalesced into galaxies. Void galaxies are a fascinating subject of study, because they have lived their entire lives in a very different environment from the galaxies in clusters and filaments. The galaxies we know best, including our own Milky Way, have lived in relatively crowded environments. They have interacted with neighbors, they have experienced mergers, they have been bathed in radiation from nearby active galactic nuclei. They have had their gas stripped by the intergalactic medium in clusters. Their evolution has been shaped by their surroundings in countless ways. Void galaxies have had none of that. They have spent their entire existences, billions of years, in relative isolation, with fewer neighbors to interact with a quieter and less disrupted environment, and they show it. Void galaxies tend to be bluer than average, which means they are forming stars more actively than their cluster counterparts. They have held onto their gas for longer because nobody has stripped it away. They are, in a sense, younger looking than their ages would suggest, preserved by their isolation, by the quiet of the void that has surrounded them for all their billions of years. Imagine being one of those void galaxies, a spiral of hundreds of billions of stars, rotating gently in a space that in every direction extends for dozens of millions of light years before reaching anything else comparable in size. Your nearest galactic neighbor might be 20 or 30 million light years away, far enough that the gravitational interaction between you and it is almost negligible, far enough that light from your nearest neighbor takes 20 or 30 million years to reach you, and vice versa. You would be turning slowly in the greatest solitude the universe offers, without the constant company of clusters, without the gravitational harassment of passing neighbors, without anything disturbing your slow and stately rotation. You would be, in the most complete sense of the word, alone, and your stars would be forming from your gas undisturbed, following their own internal rhythms, without the outside interference of environment. If there were planets in that void galaxy, and there is no reason to believe there are not, and if there were life on those planets, and that is a question we genuinely cannot answer, then anyone looking out at the sky from those planets would see a very different universe than we see from Earth. They would see a sky less rich in galaxies. Their closest galactic neighbors would be much further away, and in the direction of the void's interior, they would see vast stretches of sky with almost nothing in them at all. Not the kind of sparse sky we see from Earth, which has plenty of structure. Something genuinely emptier. A sky that tells you, more directly than ours does, just how much of the universe is nothing. Beyond the sparse galaxies of the void, there are other residents worth thinking about. Stars that live between galaxies, not in any galaxy at all. These are called intergalactic stars, or sometimes intra-cluster stars when they orbit within a galaxy cluster. They came to be there through violence. Galaxy collisions and tidal interactions can strip stars from their parent galaxies and send them flying outward. Some of those stars are ejected from the galaxy entirely, sent into the intergalactic medium at high speeds. They then spend the rest of their lives, billions of years, drifting through intergalactic space, not orbiting any galaxy, not warming any planet that could easily detect or map them, just burning quietly in the enormous dark between galaxies. We have evidence for these stars. In some galaxy clusters, the combined light between the cluster's galaxies is much brighter than it should be if the only light came from those galaxies themselves. There is diffuse light that does not belong to any galaxy, light from stars that are drifting freely between the galaxies. Those stars are among the most isolated objects in the universe. Each one a sun, perhaps a sun with planets, burning its fuel in a space so dark and so vast that the nearest other star might be millions of light years away. They live in a silence we can barely imagine. Their light travels outward into a darkness that goes on for far longer than the light can travel in any stellar lifetime, and they do not know this. They are simply burning, simply being what stars are, which is hot and sustained and gradually consuming their hydrogen. The void is their home and they carry no opinion about it. They simply shine. There are also rogue planets in the void. Planets that formed around stars and were then ejected by gravitational interactions within their planetary systems, sent tumbling outward past the edge of their solar system and into interstellar space. And some of those interstellar planets were themselves ejected from their galaxies by subsequent gravitational interactions, ending up in the intergalactic medium. These are called free-floating planets or rogue planets, and we have detected some in our galaxy and in nearby galaxies through a technique called gravitational microlensing. When a planet drifts between us and a distant star, its gravity briefly bends and amplifies the star's light in a distinctive way, and we can detect that amplification. Count the events. Estimate how many rogue planets must exist to produce that many events. The answer is staggering. There may be more free-floating planets in our galaxy than there are stars, many times more, by some estimates. And if even a fraction of them have been ejected into intergalactic space, the void may be home to more planets than galaxies. Dark, cold, without a sun, without any obvious source of heat or energy at their surfaces, but planetary. Rock and ice, and perhaps the frozen remnants of chemistry that once happened on their surfaces under the light of a star they no longer remember. These worlds drift in the void as silently as anything can drift anywhere, turning slowly in a space so empty that the word alone does not begin to cover it. The temperature of the void is close to absolute zero. The cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, has a temperature of about 2.7 degrees Kelvin. That is 2.7 degrees above the coldest temperature that is physically possible. It is cold in a way that no human technology has achieved, and the void has been at approximately this temperature for a very long time, and will remain near it for a very long time to come. The very slight warmth that comes from the cosmic microwave background is the void's only significant heat source. There are no nearby stars to warm it, no galaxies close enough to matter. Just the ancient cooling glow of the universe's own birth, stretched by cosmic expansion until it has become the coldest ambient temperature in existence. In the void, a rogue planet sitting in that darkness would radiate its own internal heat slowly into a surrounding that offers almost no warmth in return. Its surface would be at temperatures hundreds of degrees below zero, far below anything on Earth, even at the poles in midwinter. Its atmosphere, if it still had one, would have long since frozen and collapsed onto the surface, lying there as a layer of frost. Its oceans, if it had had them, would have frozen to the rock billions of years ago. It would be a world of ice and darkness and absolute cold, drifting in the absolutely cold void. And yet somewhere deep inside, if the planet is large enough, there might still be heat. Radioactive decay produces heat in planetary interiors on geological timescales. Even a rogue planet, cut off from its star for billions of years, might still have a warm interior, heated by the slow decay of uranium and thorium and potassium in its rocky mantle. Not warm enough to support life as we know it on its frozen surface, but perhaps warm enough to keep liquid water somewhere deep underground, beneath the ice, in a pocket heated by radioactivity and insulated from the void by kilometers of rock. A tiny, improbable, invisible possibility. Warmth in the coldest place the universe offers. Life, perhaps, in the emptiest place we know. There is something called the kinetic Sunyaev-Zeldovich effect, which is one of the more poetic names in all of cosmology. When the cosmic microwave background photons pass through a galaxy cluster, they interact with the hot electrons in the cluster's gas. This produces a characteristic distortion in the spectrum of the microwave background that astronomers can detect. But the same effect, in a different form, can also be used to map the motion of large-scale structures through the universe. And when astronomers have used this technique to look at the motions of matter on the largest scales, they have found something remarkable. The matter in the universe is not simply expanding uniformly outward from a common center. It is also flowing toward the denser regions of the cosmic web, flowing along the filaments toward the great clusters at their nodes, and the voids are the source of some of this flow. Matter at the edges of voids is being pulled out of the void and toward the surrounding walls and filaments. The void is slowly draining, very slowly, on timescales of billions of years. But the flow is real, and it is measurable, and it is one of the ways that the cosmic web sustains itself. The voids feed the filaments by giving up their matter to them, and as the voids drain, they expand to fill the space left by the matter that has left. The void is generous in the way that only things with vast reserves can be generous. It gives and expands and gives again and barely notices the loss. There is something called the baryon acoustic oscillation scale, and it is one of the most elegant pieces of evidence we have about the origin and evolution of the universe. In the very early universe, before atoms had formed, the matter was a hot plasma. Protons and electrons and photons were all coupled together, bouncing off each other, moving as a single fluid. In that fluid, sound waves propagated, real sound waves, in the sense that they were pressure disturbances moving through a medium, not the kind of sound you can hear, since the frequency was far too low and the medium far too different from air, but acoustic disturbances moving through the primordial plasma at roughly half the speed of light. And when the universe cooled enough for atoms to form, about 380,000 years after the Big Bang, those sound waves froze. The coupling between matter and radiation broke. The plasma became a gas of neutral atoms. And the sound waves stopped, leaving behind a fixed pattern in the distribution of matter, a characteristic scale, a particular distance, roughly 500 million light-years in today's expanded universe, at which galaxies are slightly more likely to be found than at other distances. This is the baryon acoustic oscillation scale, and astronomers can measure it in the distribution of galaxies. They use it as another kind of standard ruler, like the Type 1 supernovae we discussed in other journeys, to measure the expansion history of the universe. The voids are part of this measurement. Because the voids are defined by the absence of galaxies, and the distribution of voids reflects the same underlying acoustic scale that defines the distribution of galaxies. The voids are not just empty, they are empty in a particular structured way that carries a record of sound waves that rang through the universe before the first star ever formed. The emptiness is an echo. The voids are a frozen song from the dawn of the universe, written in negative space, readable only if you know what pattern to look for. The universe has structure on the very largest scales that we are still trying to understand. Above the scale of galaxy clusters and the voids between them, there are larger structures. Galaxy filaments stretching for hundreds of millions of light years, galaxy walls extending even further, and at the very largest scales. Structures that push against the limits of what the standard cosmological model predicts should exist. The Hercules Corona Borealis Great Wall, discovered in 2013 through an analysis of gamma-ray burst locations, is estimated to extend somewhere between 6 and 10 billion light-years across. If confirmed, it would be one of the largest structures in the observable universe. So large that it challenges the cosmological principle, the idea that the universe looks the same in all directions and on all scales above a certain size. A structure that large should not exist in a universe that is truly uniform at the largest scales, and yet it appears to be there. Or something is there. The observations are still being debated and refined. The statistics are still being contested, but the possibility that the universe contains structures larger than our cosmological models comfortably accommodate is a genuinely open question, one that means the voids between those structures might themselves be larger and more fundamental than we currently know. The story of the cosmic void is still being written. The void is still offering up its secrets, slowly, to the astronomers who are patient enough to keep looking into the emptiness and asking what they are missing. Sound is impossible in the void, not because there is nothing to carry it, which is a common misconception about space. Space is not perfectly empty even in the voids, as we have discussed. There is thin hydrogen gas. There is dark matter. There is the cosmic microwave background. But the density of matter in the void is so low that the mean free path of a gas molecule, the average distance a molecule travels before colliding with another, is measured in millions of kilometers. At that density, you could shout in the void and the sound wave would travel no meaningful distance before it simply ceased to exist. Each molecule would move freely in its direction without encountering another molecule to pass the disturbance along to. The sound would dissolve, not echo, not carry, not fade gradually, simply dissolve, into the background of random thermal motion that is indistinguishable from silence. The void is the most complete silence in the observable universe. Not the silence of a room after everyone has left, not the silence of a mountain at night, not even the silence of deep space between stars. The silence of the void is structural. It is built into the density of matter there. It is not the absence of a sound that might otherwise be made. It is the impossibility of sound. A region so empty that the concept of acoustic communication does not apply. No signal of that kind can propagate. No disturbance of that kind can travel. Whatever happens there, whatever rogue planet drifts through whatever trajectory, whatever intergalactic star burns out its last hydrogen and contracts toward its end, the void offers no medium for that news to travel in. Each event is its own island, surrounded by a silence so absolute that it does not even require a listener's absence to be complete. It is simply silent because silence is the only option available. There is a concept in certain traditions of contemplative practice called the ground of being. It refers not to any particular thing, but to the underlying reality from which all particular things arise, the space in which events occur, the silence in which sounds happen, the stillness from which movement emerges. Different traditions describe it in different ways. Some call it emptiness. Some call it the void. Some call it awareness itself prior to any particular content of awareness. The cosmic void is of course a physical structure rather than a spiritual one. It is a region of space defined by its low density of matter, not a metaphysical concept. But it is useful to notice that the qualities that make the cosmic void what it is, its emptiness, its patience, its lack of urgency, its enormous and uncrowded scale, are qualities that contemplative traditions have long associated with the most restful states available to the human mind. The mind that has become very quiet, that has temporarily released its hold on the particular and let the particular dissolve into something less specific, is doing something that has a physical analog in the cosmic void, not because the universe is conscious or because physics and meditation are the same thing, but because the qualities of emptiness are restful regardless of scale, whether the emptiness is in the mind, releasing itself from the grip of particular thoughts, or in the largest structures of the universe. Releasing itself from the grip of particular matter, the quality of that release has something in common. It is the permission to be nothing in particular for a while, and that permission is what sleep requires. The experience of contemplating a cosmic void, really sitting with the idea of it, can do something interesting to the sense of urgency that days create. When you hold in mind the fact that there is a region of space 300 million light years across, a region so old and so empty that it has been draining and expanding and simply being quiet for longer than the Earth has existed, a region where the nearest galaxy to any given point might be 10 or 20 million light years away, where a planet could drift for longer than the age of the solar system and never encounter another object large enough to see with the naked eye. When you hold that in mind even approximately, the sense that anything must happen tonight becomes difficult to sustain. Not because tonight does not matter. Tonight matters. You matter. Your rest matters enormously, both to you and in a small way to everyone who will interact with you tomorrow after you have rested. But the urgency that prevents rest, the feeling that thoughts must be turned over again and that problems must be visited one more time before sleep is permitted, that urgency is very small beside the void. The void does not have urgency. The void does not have problems to revisit. The void simply is, large and cold and patient and genuinely without anything that needs doing in the next several billion years. And if you can borrow even a small fraction of that quality for the next few hours, that is enough. That is more than enough. In recent years, cosmologists have been using voids not just as objects of study, but as tools. The shapes and sizes and distribution of voids carry information about the nature of dark energy, the mysterious component that appears to be driving the acceleration of the universe's expansion. Because dark energy affects how fast the universe expands, and because the expansion rate affects how fast voids grow, the statistics of void sizes and shapes are sensitive to the properties of dark energy. By measuring many voids across large surveys of the universe and comparing their properties to predictions from different dark energy models, cosmologists can test and constrain those models. Voids, those great empty spaces that might seem like the absence of information, turn out to contain some of the most useful cosmological information available. The emptiness is not empty of meaning. It is a record of how the universe has expanded and how gravity and dark energy have competed over cosmic time. Reading the voids is like reading the negative space in a painting. What is not there tells you as much as what is. The shape of the absence is itself a message. The cosmic void is also home to a particular kind of quietness that is different from ordinary quietness, not just the absence of sound, which is trivially true in space, but the absence of radiation. The void is one of the few places in the universe where the electromagnetic radiation environment is truly minimal. Inside our galaxy, we are bathed in radiation from nearby stars, from the galactic center, from supernova remnants and pulsars in active regions. In a galaxy cluster, the intergalactic medium itself glows in X-rays from the hot gas that fills it, but in the deep void, far from any galaxy, far from any star, the radiation environment consists almost entirely of the cosmic microwave background, the ancient, cold, uniform glow of the early universe. No X-ray sources nearby, no ultraviolet from young stars, no radio from pulsars, just the faint, all-pervading isotropic warmth of the background radiation. In every direction, exactly the same. No brighter patch, no darker patch, no local source. Just the universe itself, glowing uniformly at 2.7 Kelvin, a whispering presence that surrounds you equally from all directions and comes from the very beginning of everything. There is something about that uniform, isotropic, directionless presence that the mind finds restful in the same way it finds a steady rain on a roof restful. It is not exciting. It is not surprising. It is simply there, the same in every direction, patient and ancient and continuous. Let your mind drift into that. The cosmic microwave background is in this room right now. It fills all of space, including the space you are occupying right now, passing through you without interaction, invisible and harmless and ancient. The oldest light in the universe is touching you right now, from every direction at once. The radiation from the dawn of time is here in this room as it is everywhere. You are bathed in the oldest thing there is, the first light, the echo of the universe's birth, and it is so cold and so faint and so uniform that you will never feel it, but it is there. It has been there since long before the earth existed. It will be there long after the earth is gone. And tonight, in this room, in the dark, it is simply and quietly present. The way the void is present, the way emptiness is present, not as an absence, but as a kind of ground, the ground beneath everything, the background against which all the structure and light and warmth of the universe appears. There are researchers who spend their careers studying nothing, not metaphorically, but literally, the physics of emptiness, the properties of the vacuum, the nature of the void. They are called cosmologists and theoretical physicists, and their work takes place in equations and on computers and at enormous telescopes that map the large-scale structure of the universe. And when they talk about voids, they talk about them with a kind of quiet enthusiasm that suggests they are not merely studying absence, but something that feels to them like presence. Like finding that the spaces between the notes contain as much music as the notes themselves. The void is not a failure of the universe to fill itself in. It is a feature. It is the necessary counterpart to the structure that surrounds it. Without the voids, the filaments in walls and clusters would have no definition. They would be background without foreground, structure without contrast. The void gives the cosmic web its shape by being what the cosmic web is not, and in doing so, it makes the whole thing visible. The emptiness is what lets us see the form. If you were traveling through the universe at enormous speed, as we are doing in our imagination tonight, you would notice the transition from filament to void. It would not be a sharp boundary. There is no wall, no fence, no visible line where the filament ends and the void begins. Instead, there would be a gradual thinning. The galaxies around you, which in the filament are separated by a few million light years, would begin to appear less frequently. The gaps between them would grow. You would pass one galaxy and then travel further than you expected before encountering another, and then further still, and then you would look in every direction and find that the nearest galaxy was 20 million light years away, and then 30. And the feeling, if you could have a feeling at that scale, would be something like the feeling of walking out of a crowded city into the countryside. The density of things simply falling away. The space between you and the next thing you can see growing larger and larger until the space itself becomes the dominant fact of your experience. Not the galaxies, the space. The enormous, undisturbed, featureless space that goes on in every direction without offering you anything except itself. And yourself. That is what the void offers. Itself and you. Nothing in between. Nothing to mediate the experience. Nothing to catch your attention or redirect your focus. Just the space and the stillness and the faint warmth of the ancient background radiation equally present in every direction, and whatever you have brought with you from the world you came from. And in the void, at that scale, what you have brought from the world will feel very small and very quiet. The troubles you carried in, the questions you could not stop turning over, the lists and the worries and the half-formed plans. In the void, they become very small, not unimportant, but small. Small the way everything becomes small when you are floating in a space 300 million light years across. Small the way a grain of sand is small on a beach that stretches to the horizon. Still there, still yours, but no longer requiring your full attention. Because the full attention of anyone in the void is gently, unavoidably taken up by the void itself. And then there is the return. Because every imagination that travels out must come back. Every mind that ventures into the cosmic dark eventually wants to return to the warm particular room it started from, and the return from the void is its own kind of comfort. Crossing the threshold back from the emptiness into the first thinning of the cosmic web, the first suggestions of structure, the first distant galaxy that tells you that you are no longer in the deepest emptiness, that something is there, that the universe is still doing its intricate and ancient work of pulling matter together and forming stars and lighting the dark. The return from the void is like the first warmth after a long walk in the cold. Not dramatic, not a shock, just a gradual increase in presence, a gradual increase in the number of things that are simply there, and by the time you are back in the local universe, back in the region of the cosmic web where the Milky Way lives, back in a neighborhood with other galaxies at reasonable distances. The void is behind you, very far behind you, already receding as the universe expands, already somewhat larger than it was when you entered it, patient and generous and indifferent and still. And you are here, back in the warm, back in the particular, back in a room that has a temperature and a surface and a weight to it, and a quietness of its own, a quietness that is not the impossibility of sound as the void's quietness is, but the gentle and chosen quietness of a night when nothing needs to happen. Your quietness, tonight's quietness, the quietness of a person who has traveled far in their imagination and come home and is ready to rest. Your breathing is slow now. Your body is heavy in the comfortable way, the way that means it is resting rather than exhausted, the way that means the surface beneath you is doing its work and your muscles have been released from the effort of holding yourself together. You can feel, perhaps, the weight of your own eyelids, not an unpleasant weight. Not the weight of a long day that has not been put down yet, the weight of permission, the weight of having been given, by your own body and by the enormous patience of the universe, the license to stop, to be still, to drift. The void is still out there in the direction of boats, 300 million light years away in that part of the sky, slowly expanding, slowly draining, doing nothing in particular with complete and total commitment. It has been doing nothing in particular for longer than the earth has existed, and it will continue doing nothing in particular for longer than anyone has a useful way to imagine. And you can borrow that quality just for these few hours, just for the duration of a night. You do not have to sustain it. The void will be there doing it for you, at scale, endlessly, whether or not you are paying attention. You can simply let the fact of it rest over you like the most patient blanket imaginable. 300 million light years of comfortable nothing. Available on loan. For tonight, close your eyes if they are not already closed. Let the darkness behind them be the darkness of the void. Not a frightening darkness, not an unfamiliar darkness. This darkness has been here since before the stars. It is the original state of the universe before light existed. Darkness is not the absence of something. It is the presence of the most ancient thing there is. The darkness of the void is older than every star that has ever burned, older than every galaxy that has ever spun. It is the ground of everything, the canvas before the painting, the silence before the music began. And tonight it is gentle. It is warm enough. It is exactly the right kind of dark for sleeping. The rogue planets drift in it somewhere far away, cold and patient and indifferent to the concept of urgency. The intergalactic stars burn in it, tiny and isolated and completely at home in their solitude. The void galaxies spin in it, blue and calm and unhurried, forming their stars at a pace that suits them and nobody else. Everything in the void is doing only what it is doing, nothing more. Nothing is rushing, nothing is trying to finish before tomorrow, nothing is reviewing the day or making a list of things left undone. The void has suspended all of that, and tonight, so have you. Let the last thoughts of the day drift past you the way rogue planets drift through the void. You can see them, you can let them go. They are not asking you to hold them. They never were. They simply drifted through and will drift away if you let them. Let them go. Let the void receive them. It is large enough. Tonight we visited the spaces between the spaces. We went to the places where even the cosmic web grows thin and disappears, where the universe's preference for structure gives way to its preference for volume, and volume wins in a landslide. We visited the great voids, those enormous ancient regions of near emptiness that make up most of the universe by volume and almost none of it by fame, because fame requires witnesses and the void has very few. We met the void galaxies, isolated and blue and quietly productive, forming stars without interference from a crowded environment. We thought about the intergalactic stars drifting in their incomprehensible solitude, burning for billions of years in a darkness that never shows them another star close enough to matter. We considered the rogue planets, cold and dark and drifting, carrying inside themselves the frozen memory of systems they were born in and long ago left. We felt the cosmic microwave background, ancient and uniform and present everywhere, including here, including now. And we let the enormous patience of the void, 300 million light years of unhurried emptiness, settle over us like permission. Permission to stop, permission to be still, permission to let the day go and the night come, and the sleep arrive without any further assistance from the mind that has been working all day and has earned its rest. If these journeys help you find that rest, I hope you will subscribe to this channel and return whenever you need a quiet place in the cosmos to spend an evening. There are more of these waiting for you, more slow travels through the universe's quietest corners, and if tonight was good for you, please consider leaving a like or sharing it with someone who could use a calm night. It means a great deal, and it helps other tired people find their way here. Thank you for drifting with me tonight. The void was glad to have you. Now let it carry you the rest of the way. Let everything go still. You have been still for a while now, still enough that the stillness itself has become comfortable, not the stillness of effort, of holding yourself in position, the stillness of release, the stillness of the rogue planet, drifting without needing to steer, the stillness of the void galaxy, spinning in its enormous solitude, forming its stars at its own pace, without a schedule, the stillness of the cosmic microwave background, 2.7 Kelvin in every direction, patient as the universe itself. This is the stillness available to you right now. This is what the void lends you, at no cost and without asking anything in return. You can have it for as long as you need it. The void will not run out. Your breathing is already where it needs to be. Your body already knows how to sleep. You have done it before, many thousands of times. Tonight is not different. Tonight you simply let go a little earlier than usual and trust that the body and the night will do the rest. The void is out there in the dark. The The pulsars are ticking. The rogue planets are drifting. The stars in the void galaxies are being born and living and dying in the most peaceful environment the universe offers. And you are here. Warm, still, safe, completely and unremarkably and gloriously allowed to sleep. Sleep well, and good night.